Hey guys, so we're up here in beautiful Seneca, South Carolina at the home of Greenfield Industries, and I am really excited about this. I have Rhett Keaton standing here next to me, and they have invited us up here to check out the factory and see how drills and taps are made. And I'm looking forward to it, man.
We're looking forward to it as well. It's not every day we get a third generation machine shop owner here with us, and we've been watching A-Bomb 79 for some time, so we're glad to have him inside the building here at Greenfield.
Yeah, this is going to be excellent. So you guys have been watching my videos. You know I'm big fans of the Cleveland brand. I use a lot of those in the shop, high quality cutting tools. I have never had the opportunity to see up close in person how cutting tools are actually made. I know how they're made, I've just never actually seen them. So we're really excited about this tour. We're going to get to see a lot of fun things, and I'm excited. Let's go check out some cutting tools.
Fluting, clearing, and pointing. How about that?
Let's do it.
All right.
All right, so I'm standing here with John. He is the plant manager here at Greenfield Industries, and he's going to be giving us the tour, and looking forward to it. What can you tell us about what you just said about what we're looking at right here? This is part of your inventory, right?
It is. This is our raw material.
Okay.
So all the raw material is stored here. And you can see we have a lot of raw material. This is really to hedge, obviously. We want to make sure we don't have any issues with anything incoming. This is where the process starts. We start here with our traveler. The work order is going to go through the process and go through each of the grinding operations. So they're going to pick the material here, and then we get to the fun part when we get out to the shop where they start grinding on the blanks.
Very cool. Well, this is going to be great. This is definitely a lot of raw material I'm seeing in here. All of your jobber drill blanks.
It is.
All different sizes.
It is, and it goes, down to 76s, all the way up to 1.5 inches, 2 inch even. So
wow.
We got some large tools in here as well.
Okay. Well, I'm excited about this. Let's go get our tour going.
All right.
Well, this must be the grinding shop here.
It is the grinding shop. So this is where the raw material first enters the shop. It's obviously where the safety glasses are required too, but let's head through here.
Wow. Looks like a nice big Greenfield arbor press right there.
Ah, good.
Hardens lathe.
So what's cool about this grinding shop is we got modern investment and we've got the old school machines. And to me, it's a perfect mix, right? You can't just stick with the legacy machines and say, hey, we're old school American quality, and that's great, and you can't get a tool like that anywhere else. That works, but you also got to invest, right? So we're doing both, and I think that mix puts us in a really unique spot. And it starts here first with fluting. We can take a look at some of the machines here and see how the process runs.
Okay.
So basically we're running a big job shop here, right? There's hundreds of machines all over the place, right? And to really understand the process, it's easier just to show you here with the individual tools. So this is a typical tool that we sell. We start with a blank. We saw the blank store earlier. First process here is nitride. So we nitride the blank on certain applications. Next process is we flute the tool. After fluting the tool, that's an optional reduced shank on this one. You can see it's got a 3/8 shank on it.
Yep.
So perform that process. Then it goes to steam oxide. We run the tool to about 990 degrees, apply some steam, get that black color, helps with lubricity too in the final product. After that, we flatten the tool. So you see the 3 flats on there?
Yep, right here.
Yes. And then this is that clear diameter that we discussed earlier. So then we do the clearing operation. After the clearing operation, we point the tool. You see that on it? And then after pointing, depending on the style of the tool, in this case it's split point, and you can see the split point on the tools here.
Yep.
And then we have the optional straw color to make the black and gold tool. And then the last operation, you can see the laser mark is on the tool. So this is really a full process for a tool that takes all of our operations here.
Okay, makes perfect sense. So I guess we'll get to see most of these processes from start to finish. Then.
Absolutely, absolutely.
Okay.
Yep, we just covered fluting, and next we're gonna go to the clearing area.
Okay, sounds great.
We load the tools, fluting both sides.
You'll notice there's what we call a saw point on one side.
Yep.
That right there, that's going to be the point of the drill, and this is the shank. So the shank is actually a little bit softer than the point side.
Okay.
And it's a little softer, that way when you put it in the drill cup, it'll actually bite it.
Yep.
And it'll hold it.
Okay.
If you have to be fluted backwards, it'll be biting this side, it'll slip in the cup.
Yep.
So, they run through a machine and we got a colic in there holding that thing. We got a lead back here. we got different size leads for different whatever we running, and that's what puts the twist in it.
Okay. Now is that grinding it?
Yeah.
That's grinding it.
Wheel.
Okay.
Yeah. And the pin right here, it goes down through where it sticks in there. It's riding on that pin.
Okay.
Keeping that thing running.
Yep. So it's going to spit it out here whenever it grinds the flute?
Yeah.
What's going on, sir?
That is super cool. It's the first time I've seen this operation.
This is old school right here. This ain't your CNC stuff, but it's very effective.
Yep.
I mean, we run a lot of tools on these old machines right here. I mean, they probably back in the 60s.
Yep.
When these machines were built. Back when the plant was first put here, I think it was in the 60s.
That's how far back some of these machines go, the 60s? Very cool.
And we still keep them up. They do an absolutely great job.
They've been making drills for well over 50 years then.
Yes, sir. We got a press counter right here. We got to set on 8 pieces on this one. Depending on the size of what, we get about eight pieces out of the wheel before it starts breaking down. So we try to get all we can out of the wheel.
Yeah. Do you have to dress it?
When it's right here, it dresses automatically. Yeah, when it's right here, it gets up to 8, that top number, it'll automatically dress.
Okay. Is this your finish right here?
That's the finished product, yeah.
Okay. What size drill this is? It looks like about 3/16.
Yeah, it is.
Okay.
It's actually about a 1364.
Okay.
It's a number size. It's number 10, but it's about like a 1360. It's kind of between a 3/16 and a 1360. You're right. You're real right.
Yep. All right, so it's not ground yet, so it'll go to a finishing.
Yeah,
and then
clear in there.
And then you'll have to put your relief on the side too, correct?
Yeah.
Okay.
Walking off, yes, sir.
Yeah. All right. Well, there we go. Starting off with a bang. This is cool.
All right, guys, so we saw earlier all the different processes that we have to make a drill. Clearing's a critical step. All tools are cleared unless you get a very, very tiny tool, but all jobbers and normal tools are cleared. Byron McCauley here, he's gonna help us out and show us how to run a clearing machine.
Okay, awesome.
All right.
So basically it's clearing. This how it looked before.
Okay.
So
Clearing is you're going to be putting side relief on the drill, correct?
right. We're putting the margin, we're making the margin right here.
Yep.
So basically we take this drill, it comes through the machine, and what it's doing is cutting that, making that margin, making the diameter right here to the finish. So that's what it is before.
Yep.
And then we dropping it down to 325.
Okay.
So we drop it down, and then we check the margin, and basically that's it.
That's
Put
it.
it, take it out of here.
So these guys here, that's the ones you're feeding into the machine.
Yes, sir.
That's the finish.
Yes, sir.
Okay. So once you're finished with this, where does it go after that?
They go to point.
Point it. So that's going to grind the cutting edge on the end of it.
Right.
Okay.
So basically, we just gotta make sure it go all the way down to the bottom, right here to the end of the flute, and all the way to the tip. And make sure the finger is not on the cutting edge, and that's it.
Okay. Awesome.
All right. Make all the points together. Put it in there. Come out. Come through, we check them. Make sure all of them the same way, so when the next operation get them, they don't have to be worried about going through machines backwards.
All right, so we covered the first 2 steps in the process. We fluted the tool, we've cleared the tool, and next up, we're gonna point the tool.
All right, here we have a P500 Normac point grinder. This would be the drill side. It holds the drill. You can see the head turning and point the drill. There's another spindle inside the head that's turning probably twice as fast and hitting each side of the drill. You got 2 flutes on that drill, and so you're hitting each flute. All right.
Okay.
Over here you have the wheel side. That's the grinding, doing the grinding part. And you'll see it come over and grind all the way across that wheel.
Yep.
It'll sit there and spark out, polish it up, and it'll pick up the next drill from the loader right here.
Okay.
These here haven't been pointed. What's coming out will have a point on them. This particular one right here is pointing a 135 point angle. Called a heavy duty.
It's dressing the wheel there, right?
Yep, dressing.
Okay.
Yep. And depending on what size drill you're running, how many pieces per dress you're going to dress.
Okay. What size drill are you grinding right now?
This is probably, just guessing, this is not something I've worked on today, probably about 3/16.
It looks like about that size.
Yeah.
Okay. Very cool.
Yeah.
So whenever it finishes that, the point is finished, ready to go.
It's ready to go. It drops in a catch pan.
Okay.
The operator comes by, scoops them up, does a visual to make sure that all of them are good.
All right.
And looking for defects, of course.
Yep.
And that's pretty much it.
Very cool. Love it.
Yeah, man.
Thank you for showing this to us.
You bet. Welcome to Greenfield. You can see the locator shot down, and that's what locates the drill to make sure every one of them fixed all the time.
All right, guys, we hit the first 3 operations, went through flute, went through clearing, went through pointing, and about 75% of the tools that we manufacture get a split point as well. Dale Parker here will take you through that.
Like John said, this is split pointing. What we do over here is we split both sides of the land. The good thing about this drill is you start drilling a hole, you don't have to have a hole to start with.
Yep.
It'll
Self-centered.
Self-centered. Real good drill bit. And
All right. So that's what you're doing over here in this station?
yes, sir.
Splitting it?
Yep.
Could I see that one
Yep.
real quick there? So they split the center.
Right there's before we split it right there.
All right. So right there, it's kind of like a jobber grind, like a jobber drill. And then you're going to put the splint that thins the web there.
Yep, it does.
All right.
It almost takes the whole web off.
Yep.
Very little left.
Yep. So where is this machine splitting it here?
Yes, it is.
Okay.
What that thing does, when it loads in, it'll turn around and locate that drill, and that gives your chisel angle, how or low that chisel angle is. When it goes in, you'll see it when the head goes back in.
That's your
It
finish?
located it, now it comes down and does that one side, does the 180 and does the other split.
Okay. It's just ejected them out here, the finished grind?
Exactly.
Okay.
All these coming out here is already finished.
Yep. So you can't really see it because it's guarded up. You got a grinding wheel in there that's going to grind one side, it's going to rotate at 180, it's going to grind the other side and spit it on out right here.
Exactly.
It's already ground, but all this machine is doing is going to each side and splitting the web there in the center to create your chisel point. You got drills going in here, and then once it grinds both sides, it'll just eject them there into the pan. Might be a little hard to see, but that's your split point there on the end of that drill.
All right, guys, we're back here. We've got Tommy Fisher in the degrease blackening area. There's two operations that happen back here. We're doing the steam oxide process as well as the straw process to put a gold color on the tool. But Tommy can walk us through it.
Okay.
Okay, what we're doing here, we're taking the oil off the drill bits where it's blackened. So, put them in here, we're degreasing.
That's this right here. It's going to clean the oil off of
Clean the
them.
oil off of it.
Okay.
And it's the only part here, it's got to go in next.
All right.
And right here. This is the hot, but I actually just got through running this and I was fixing to take it out. That's the blackened part.
You can definitely feel the heat coming out of here. Yeah.
All right, guys, we're here at our Cooper-Matic filtration system. All of the machines here, we're grinding on hardened blanks, so we got to use grinding wheels. Grinding wheels require a special type of oil to keep it cool, lubricated. That oil is pumped out to the machines from a central system, and it comes back gravity-fed into this massive pit. It is then filtered, and filtered to such a level that we're able to recycle that directly, not as scrap. So it's considered a raw material at the level that we ship it back overseas to get reprocessed again in order to get new material in.
That's pretty cool. That's not something that a lot of us probably think about, is the waste from the cutter itself that you're grinding away, that you're capturing and recycling to put back into the product.
And it's an ideal waste, right? Because you're talking about something that's ground almost into a powder.
Yeah.
And there's very little contaminants. You got a little bit of grinding wheel, you got a little bit of diamond from cleaning up the grinding wheel, but it's really high-speed steel is what you got. So it's great to recycle that. And for a legacy or an old school kind of, what do you want to call it, factory that we have, it's surprising to be that green. A lot of distributors are shocked to say, wow, you're 80% recycled material. I said, yeah, we get everything back.
Yeah, that is so cool, man. This is the oil that's already been filtered?
No, so this is the return oil that's gravity fed back.
Oh, okay, yeah, into this pit.
And then it's coming back into this pit to be filtered here by the Cooper-Matics. And
Okay.
then we're pumping fresh oil back out to be
I got you, I follow you, okay.
So you guys saw a lot of drills already, and you're seeing different diameters. We also make these little tiny ones, right? You look at some of these tools, you get down here at 76, 78, you're talking 20 thou diameter,
Yeah.
right? So these tools are only getting a couple operations. They're getting fluted and they're getting pointed. They're not always getting cleared when they get that small, and definitely not split pointed. So what's interesting is, I mentioned this at the beginning, we got a lot of these older machines that make quality that you just can't get anywhere else, but you got to stay relevant and invest. And this is a great example of that. This is an FCP4. It flute clears and points up to 4 millimeter, but also goes down to these micro minis and produces those tools for us, tools complete.
That is wicked cool.
All right, guys, we're in the end mill department now. So we make all types of different cutting tools. So we make the drills that you saw earlier. Here in the end mills, you can see we were talking about the Anka machines before. You see we got a couple rows of those. And these, in most cases, are grinding complete. We can make high-speed steel end mills. We can also make carbide. In addition, we can do custom tools. So really anything you can come up with. An example would be a special application carbide compression router. So this is obviously very specific.
I've never run one of these, but it's supposed to kind of equalize the tool pressure. Is that right?
Yeah, or if you have maybe some type of different material between to other types of material, right? You can like fold over the edges of the metal in the right direction.
Yes.
You know, think of like windows or cabinets or a lot of like melamine kind of stuff. This is where this would make a lot of sense. So that way you get a nice finish on that edge.
I follow you.
We can design that for whatever the application is and then custom make the tools here.
Yeah. This is just an example of what you're grinding here.
Yeah, these are some example tools that we produce in this department.
Yep. See a lot of roughing end mills here.
Yes.
Large diameter roughing end mills.
We also have many different types of coatings.
Yep.
So just one example here, but there's countless coatings we can put on the tools as well.
Is that a chamfer mill?
Yes.
Right here?
Which doesn't stand up as well as the others.
No. This looks like a specialized form tool right here. Ball end mill. Yep. A lot of your classic end mills that we use in the machine shop.
You can see it grinding in there too, which I think is interesting.
Yeah, so here's some of the end mills that they're grinding right here. Got a 5 flute, I don't know, about a 4-inch flute length there, maybe 1-inch diameter. And you can see it's being ground there now. Are you just putting the end grinds on it here? Is that what's happening?
Yes, looks like they're removing the tip right now because they got the tip on these ones.
Okay.
So they're removing that, and I don't know if they're doing additional operations or not.
Okay.
That's where we have to get the official spokesperson.
Yeah, he did. we had one of the fellas, he didn't want to be on camera, but that's okay.
And it is a 1x1x4.
I was right.
You were right, that's correct.
1x4.
Yep.
Well, it's not every day we get to see this kind of stuff, and you know, it's hard to see what they're doing, but it's great standing here in front of the machines and seeing how cutters like this are actually produced. All right, so this is your finished product right here. So this is what they're starting with. So you got a 5 flute roughing end mill right here. That's pretty cool. This one is center cutting as well. Beautiful. This is going to be your blink?
Correct. Yeah, and then you're exiting like this. Unfortunately in the red, but you can see its first part. And then
the red means
yeah, so they had an issue with that, and then you can see they had a good one here.
Okay.
And now they're working on part number 3.
All right.
So that's a little more explanatory.
You guys probably recognize this. This is a very common end mill. 4 fluter, 1-inch by 4-inch. Fresh off the machine right there. Here's the blank. And when they're done with it, it's gonna look like, all right, so this one is bad, it's in the red box, so I don't know, undersized or something. Here is your finished end mill. 4 flute, 1-inch diameter, 4-inch flute length, I mean. Beautiful end mill right there.
All right, now we're in the threading department. So we're manufacturing taps in here. We're also manufacturing dies. Dies are from soft steel. So those actually go out to heat treat and they're really made from scratch. We're starting with a hardened blank in taps. So you see, this is how we start in taps. We're fluting a tap. We're doing the spiral point or gash. We're threading the tap, and then we're doing that lead-in chamfer as our last operation.
Okay.
And so that's what the machines behind me here, that's the operations that they're performing. We're also at the point here where they have their production meeting. So we got the big screen here, so the guys at the start of all 3 shifts.
A little example here of what
So we do the spiral flute, we do the spiral point we talked about, a lot of straight flute. We've got the pipe taps as well. So we do the interrupted pipe taps. There's a lot of different tools we can make here.
Yep. There's your pipe tap right there. And of course you got some of your dies. Yep.
All right. So let's take a walk through the department.
All right.
Came back from break, actually. So I'm picking up right now my machines.
7 out of 10. That'll work. 7 out of 10 should.
So I'm just checking that one. But this Drake is what it's called, and it's threading number 10 blank right now, number 10 tap. And it threads, you can see in there.
Okay, there's your rotation.
That's the grinding wheel.
Okay.
And then there's the part turning in between it. And these have already been fluted.
Okay.
And gashed. They've actually been fluted and gashed. They look like this.
This is the one that you're grinding right now?
And then it'll turn into
okay, so there it is, putting the threads on.
Mm-hmm.
So this one's only grinding the threads, right?
threads, yes,
okay.
sir.
Yeah, it'll go through a secondary process of grinding the relief on the end, the
chamfer.
The chamfer, yeah.
Yes, sir.
Okay. All right.
And then this machine's just fluting. It's just a straight hand tap.
Okay.
Just fluting the flutes.
That's these guys right here?
Yeah, these are called FX5s. They're made by Anka.
Okay.
And they run like 210 pieces at a time.
Oh wow! So here's
they unload right there, and I'll top it off, you know, every so often and check, make sure it's good, all that good stuff.
That's cool. So it's got a robotic arm in there that's doing the loading and unloading.
It loads and unloads. These also have a robot too, but they actually just dump out. We don't have them going into a pallet.
Right.
They just go into a little inspection tray right there for
Yeah. That is totally cool though. So you're going to put a batch in there.
Yes, sir. So
And
they're blanks. They just start out, well, here's something right here. They just start out as a blank.
Yep.
And then it gets fluted and turns in. So this.
4 flute.
Yeah, 4 flute, number 10.
This is a number 10?
Yes, sir.
Okay, so it's going to grab one of these, put it in there, grind the 4 flutes on it, put it back in the rack. Okay, number 8 taps over here. Yep. Just putting the flute.
It's doing flute and gas. I'm gonna try to pause it off where you can see it. But it's fluting and gas. It's a 2 flute. That's how we load them up.
That is cool.
And then they come out. Got a little bear on it. It comes out and it's got a flute and a gas on it. And it does both operations.
Okay.
So
Those are your unfinished.
Yeah, that's
They're just going to put them over here.
That's the unfinished.
So do you run through all this in one cycle?
Yes,
and then
sir.
reload them?
Yes,
okay. There's your number 8 tap that's got your straight flute ground on it. All right, there you go.
Hit start. Loaded. Something over there to pick it up. Unload that one and put another one in there. Okay, this one is threading like all 80 number zeros.
Wow.
And you have to use a scope to be able to really see those threads.
Yeah, these are tiny, tiny. I'm glad that I don't actually have to use these.
More for like dental and
yeah,
stuff like that. Little, that's what I've heard.
But this one is putting the threads on, correct?
Yes, sir.
Okay.
Yeah. It's just there's the fluted one. It's just a straight 2 flute.
Okay, yeah, that's your blank.
Yes, sir.
And it puts the threads on.
But over here at this tail, we only run 90% of the time number 10s and below.
Oh, okay.
All the small stuff.
You do the small guys over here.
Yes, sir.
Okay.
Yep.
Maybe we'll see some of the bigger ones, the big boy stuff down there.
Yeah, yes, sir.
This is cool video to get anyway, just because we have a collaborative robot here. So it goes back to the investment that we're making, right? We're not just resting on our laurels, so to speak. So collaborative robot, they are common in a lot of industries, not so often in ours, but you can, you see no cage, no nothing, right? You can bump into it, it stops, you reset it, it takes off. And so that way we're able to run, I think we're running, what's your cycle time? 1:15 cycle time. We don't need Michael standing here all day waiting on a 1:15 cycle time, right? So now this collaborative robot just grabs the next tool, puts it in, and it keeps the machine rolling.
There you go. The robot will grab it. What size cutter are you working on here?
I think they're 420s.
Okay.
Yeah, it used to be fully hand-loaded machines, so we would basically only run it if we had like some interrupted pipe taps to do or something special. But now, since we got this robot on here, we can set it up on something and let it run.
Are you grinding the threads here?
Yeah.
Okay.
Whole thing is if you barely touch it at the top. Take it back off.
Gonna grab one ready for the next load, correct?
It's really good because a lot of the robots, if that was to happen, you have to home it out, restart it, back from the beginning. So with this one, you can just pick up where you left off.
Oh, it knows right where it's at. Cool. What
So
you doing over here?
this is our TapX. So basically, we run all of our specials and spiral fluted tools because we can run complete here. So on our other machines where we'll just flute only, thread only, chamfer, here we'll do flute, thread, chamfer. So whenever it goes in, it's a blank. Whenever it comes out, it's a complete tool.
Oh, nice.
So you can control quality. We have a little bit tighter specs over here, so you can control it a little bit easier over here whenever you're running everything complete.
So what are you working on right now then? What are you grinding?
Right now we're grinding a high helix M10 1.5 spiral fluted tool.
All right.
We're actually not threading these right now just because it's quicker to thread them over there, and they don't have relief, so it's not a big deal to thread over there. And we have a lot of work to get through over here, some specials. So the cool thing about this one is we have a robot cell back there with 15 different wheel packs. So use a different wheel for fluting, a different wheel for threading, a different wheel for chamfer. And the robot will load the wheel in, load the part in, grind the flute, come in and get the flute wheel, put the thread wheel in, grind the threads, grab that wheel out, put the next wheel in, grind that, and then take that part out, load another one, and start it all over again.
That is really cool.
So it's really nice to be able to do everything and have everything in there that you need.
Yep. That's all your different grinding wheels there for this particular machine that we were just talking about. So, so for each grinding process, it'll swap out the wheels.
Yeah. We go in the program and tell it what wheel to use. They're numbered 1 through 15.
Yep.
And if we tell it for fluting, we need wheel number 2, it'll go use that one. And then when for threading, if we're using 5 or whatever, we tell it what we're using, it knows where to go get it and bring it in. All we ever have to do is whenever the wheels get low, put a new wheel on.
Here we go. It's going to swap out the grinding wheel for a different one.
It should be going to get the part now and then load a different part and then change the wheels.
Oh, okay. That's your cutter.
Now it's going to grab the wheel.
Oh, okay. Yeah, there's your grinding wheel. Next grinding wheel. So what kind of wheel what profile is it going to be grinding now, do you know?
So now we're going to be doing fluting.
Okay.
So that's a fluting wheel. Right now we're only doing 2 operations. We're doing flute and chamfer.
Okay.
So that's our chamfer wheel. So it's just using the load and unload dock right now. It'll take that wheel and put it up into the load dock.
Okay.
So whenever it goes to chamfer, it'll be ready.
Yeah, so those 2 wheels are just going to alternate right
swap
there.
back and forth.
Yeah, I got you.
Normally if we were using 3 wheels, it would do the same thing, except it would go put one up and then put one there. Whatever the next one was going to be, would be there.
All right, guys, this is PVD coating. So we also do this in-house. We focus on tin, titanium nitride coating, which you can see here. We also do TICN, titanium carbon nitride, and we also have talon coating. It's a really interesting process because we're actually depositing titanium onto the tool. So you see here, this is the target that we're using. We take the machine down, drop a very low vacuum, and then we apply heat as well. And we're gonna have an electrode hit this, and it's gonna deposit the titanium off this target onto the tools. And you can see after that target is used, it's literally taking the titanium off that target, and this is a used target when it's expended. because all that is now on the tools themselves.
That's interesting, yeah.
It gives like a ceramic coating to the tool, and it extends tool life by up to 4 times.
Yeah.
It's a significant difference in tool performance when you have a coating on there.
Isn't it supposed to add a little bit of lubricity as well? You know, when the shearing action of the chip sliding across the flute?
It can, because it's a different composition at the tip now, right?
Yeah.
You're not just on the high-speed steel, but you're on that, it's almost like I said, ceramic type coating.
Yeah.
So now you can see here, this is the coating facility. We've got coaters on either side. This is a finished rack that was just pulled out. See, he removed that from the machine. You can see all the tools now have their coating on them. And you can see all the different diameters that are in there at the same time. And we got fixtures for each one, and it allows us to run different lot sizes. You also see that there's threading tools in there as well. You see the small taps that are in there, and of course the jobber drill.
These are some of the drills and cutters that have come out of the machines putting the tin coating on. See some taps in there and obviously different size drill bits. So just curious, this batch right here, so how long does this take to coat them?
Oh yeah, good question, because behind you, and we can take a look at that, but there's a cleaning operation that has to take place. So we have ultrasonic cleaners to make sure the tools are absolutely clean. Once it gets to the chamber, it has to pull that vacuum. We're in about a 2-hour pull down right now on the chamber behind me.
Okay.
So there's a lot of steps in this process. So you're looking at a 6 to 8 hour process to get a load of tools out.
Oh wow, okay. Yeah, so some time involved in just the coating process.
Yes.
Okay.
All right, we're now in the packaging department. So everything in this department, these tools, they drill holes. So from here, now we got to finish them for the customer, right? What kind of brand? We're making a lot of things to our NAS 907, I can't even say it, but the Aerospace 907 spec. So we can brand them here, we can laser the size on them, we can blacken. We got another set of blackening pots, we got straw pots out here. Laser, label, pack, though, is the main operation. So let's go take a look at it.
All right.
So we got Charles here doing the laser operation. We're picking out of these areas behind us and all around, right, where we see the tools that are finished. This is where they actually make it ready to ship to the customer. So Charles is going to take an order. He's doing orders now that ship same day. We talked about this in TAPS a little bit, but this order is going to ship same day. So he's going to scan the barcode on here. The barcode that he scans on here is going to link directly to the database that's on our website. So we know what's lasered on that tool. So he's going to scan that, he's going to load his tray, tools are going to come across, and you'll see when it goes into the laser position, you'll see the laser on the bright tool.
Oh yeah, you can see it right there.
Yep.
That's totally cool.
And on the, it's crazy too, if you're on a steam oxide tool, it goes so fast you can barely see it.
Oh yeah.
When you're on a bright tool like this, it's really got to, we want to get a nice deep mark without causing any kind of roughness on the tool. And then you have the laser mark, which you can see this is not a planned tour because we could have got a larger tool for you.
I know it's hard to see on the video here. I'm sure Abby will get a picture for us, but you know, it's cool to see this because I never would have thought that you're laser marking a bunch of them at one time. I was just thinking one at a time, you know, one after the other, you're gonna mark it, but you do a bunch of them.
We do. This is a 48 tray here, and depending on the diameter, we have as small as a 6-piece tray when we're getting into S&Ds and some of the larger diameter tools.
Yeah, okay.
So at the end here, he completes lasering it. It goes to label, and then it goes to the pack lines. And you see all those yellow SO cords coming down? That's where they're packing out all of our tools, and we'll take a look at that.
Okay. So there it's laser marking the cutters. It's putting the size on there, the logo. And it's gonna move it right on down there. And if we look behind us, they have a bunch here. Like you can see, these are all finished. So what we have here is a letter F drill, Chicago Latrobe, tap size for a 5/16 18. But that's what that machine behind us is doing, is putting the laser mark on there.
What they're doing here is they're packing out the tools. We saw earlier where they're lasering the tools. So we have a command center there where Miss Andrea is working. She's going to run the labels. The labels look something like this.
Yep.
They're going to label those tools over there, put those labels on this rack behind us, and then she's going to marry those labeled tubes to the tools, pack the inners, put the caps on, place them on the buggy to be stocked in the warehouse, or in a lot of cases ship same day. We have both processes where we can ship same day, or we stock on these larger volume tools.
Very cool.
And we have basically 5 folks doing this, and they are fast. We've looked at automated equipment, and we simply cannot beat the speed that they run.
Really?
Yeah, we've had a lot of people try, and if people are watching this think they can do it, we're talking to them.
The human touch sometimes
It
is hard to beat.
And we got 30,000 different finished goods. That's a lot of variability. It's a set build. They're producing all types of different sets here. This one's a little bit unique because she's doing a tap and drill set. So that's our 18-piece set. So she's taking the taps out of the snap packs, loading those into the index, and also taking the drills, matching them up, and then assembling the set, loading them in the box, and off to the warehouse.
Beautiful set of cutters. I noticed some of the plastic cases here loaded up with drills.
Yes, we also have the twister cups. So this one's already sealed, unfortunately, right? But it's got the attachment point here, and these are really popular now. It's amazing how many we sell compared to the steel indexes. Yes, ma'am. Oh, you got a whole stack of them. I'll go check them out.
Oh, we got some over here. They didn't sealed up yet.
Well, because sometimes Miss Shirley likes to get my help sealing these things because she would rather build than seal. But you can see here, we got a Cobalt set. Mm-hmm. This is our 6 flat.
Yep. Is this
1804 series.
These are your Cleline?
Yep. This is a Cleline 1804. Yep.
Okay.
That's an M35 tool with 6 flats.
The guys in the construction field probably really love these drills there as well because you got the flats milled on there, so you can put them in your hand drills. But these are great sets to have around the shop. Nice.
All right. All right, we made it through the whole process now. We're at the warehouse, and you can see the raw material in the very back. That's where we started everything today. And then we have our finished goods right in front of it. And then right in front of us here, we got the dock door where the tools are going out the door. So to walk us through the process, Brent Hanks is going to show us.
All right, so the process that we have is shipping the finished goods to the outside customer. So we'll walk over here so we can get a look at where the process comes in and begins.
All right.
So over here is our locations I set up in the warehouse, provide all the picking locations. There's approximately over 6,000 bin box locations through the warehouse that the pickers will pick from. There's 2 ways the picker will pick. One be a paper pick ticket, or they'll get an electronic pick in their handheld scanners, which will send them to a location. They'll come to any of the locations that you see out here. They'll grab the tool verify kind of the customer, the quantity, what they're looking at. The picker will then pick the part and then take it over to the shipping lines. Shipping line is kind of where all the magic happens at the end. So once they grab that, they drop it off at our shipping lines. These are our normal orders that's going out to the same day customers that's going to shipping UPS and FedEx. The picker will then drop it in the bin box with the paperwork and the pick ticket. The shipper will then take it and process it outside through there. So once the shipper actually takes them, they'll box them up, pack them up, and get them out the door for you.
Nice. That is really cool. I appreciate you taking some time and explaining that to us. And
okay.
You guys have a heck of an inventory out here of cutters ready to go.
Yeah, there's a lot ready. Just waiting for people to get them here.
Yep. Check out the inventory. This is just one row. They've got over 30,000 different tools in this warehouse right here that they pick from every day to ship out to customers. See what we got right here. I'm trying to find the size on it. Oh, 15/64 jobber drill right there. What's this? 1 53/64.
Very common.
So is this y'all's tool room?
Yes, so tool room here, they work on different parts for, you know, things that go down on the machines.
Yeah, it's kind of like a maintenance area,
Yeah,
right?
maintenance area for the machines mostly.
Yeah.
A lot of the bushings and parts and stuff, things along those lines.
Yeah. So you got a hardened lathe. See some old school pedestal grinders here. Let's see what one of them is. Can't tell. This one to Cincinnati. Not sure what that one is there. Powermatic belt sander. The general maintenance area. You got some electrical going on. I like the ship's wheel on the arbor press right here. That's pretty cool. Oh, that's got a really nice feel to it. That's got sort of a fine pitch rack in there, because usually they move a lot faster than that. So that's pretty cool. Couple surface grinders. I like it. So the guys that work in here obviously are going to help kind of whatever's got to be fixed to maintain for the production floor out there. They're going to be in here using some of these maintenance machines. They have a lab here where they test. They do test on all their cutters. So they got a CNC machine behind me here where they're just drilling holes. And then it's hooked up to a computer, some software, and it's showing some data here. They're drilling 1/4-inch holes, I believe, right now. And it's just showing the, you know, the force that's being applied for each hole. They get a lot of data on each hole that they drill, just to sort of measure and see what the tool life is, tool expectancy of the different tools.
But yeah, here in the lab, we test our own product to try to make, you know, improvements to the product. We test against our competition. We're always looking to make improvements. And so we've got tests going on right here, right now, on some jobber drills. And you know, this force measurement system, and you can see up on the screen, that lets us measure force. It lets us measure thrust. So we don't need to necessarily test to life. We know from the forces when a tool is going to fail and roughly how long it's going to last. So that's a big advantage for us, and it's something we do for our customers as well.
So you take a lot of your cutters, I'm assuming lots of different drills, taps,
Yes.
and you're performing different tests in here to see the longevity,
Yep.
the life, and the quality of the cutter.
Correct. We have our standard tests that we run through. We'll go through lots of different plates of lots of different holes, right, back in here. But we also take customer requests, you know, that they want to see, hey, how does this look in the lab?
Oh,
You
yeah.
know, when they got lots and lots of holes to make, and they don't necessarily want to do that in their production time.
Okay. Yeah, that's pretty cool. They might have an exotic material. They want to see how the drills are going to
Yes.
perform in that. So
Yep.
this is just a station where you're doing hand drilling, testing the different drills.
Yeah, we do a lot of training back here for our, our salespeople, our distributors, and we'll have them in here. We do a lot of hands-on with them. 135-degree split point versus a 118.
Oh, okay.
Feeling the walking that would happen on a round pipe like that.
Yeah.
We put them on a drill press. We let them drill stainless with high-speed tools versus a cobalt tool. They can feel how much better the cobalt tool performs.
Right. Well, I can't help but notice the big taper shank drill standing up over here.
Yeah,
So
that's a pretty good one.
let's take a look at that guy. I've run quite a few of those. Do you have a size on that? It looks like about 2.5.
Yeah, I think you're up around that 2.5 number right there.
What would you be doing in the lab with this guy right here?
Showing it off.
Okay, because I don't see a machine, I don't see a big lathe or anything in here.
No,
so
we wouldn't run that one back
That's
in
the
the lab.
trophy application there.
I just can't tell you how many times I have had to push these through a piece of material in I've been doing it 27 years now, and I have quite a few Cleveland too. Old
Yeah.
school.
Yeah.
I mean, I'm talking about some of these used to belong to the Navy that ended up in our shop.
Oh, yeah.
So old stuff.
Yeah.
Good quality cutters.
But
My granddad was able to get a lot of Navy surplus.
Okay.
And
I guess down in Pensacola, right?
yeah, it was off the
Yeah.
NAS Pensacola.
Yeah.
Yep. That's how he tooled up the shop, was
Yeah.
a lot of it through Navy surplus.
Okay.
And a lot of them were Cleveland drills.
Excellent. Cool.
This is very cool. Look at that guy. I like that.
Yeah, we made that here in the lab too.
There's your classic drill index. We were just talking about that,
Yeah.
but that looks like it's 3D printed.
Yeah, that's the 3D printed one.
Yep.
But that's the idea, to do something like that.
Yep.
I think that'd be kind of cool.
That's actually something I was telling them. I actually have an idea for doing something like that for myself pretty soon. So that's another discussion for another day. This is
Absolutely.
nice though. That is going to conclude our visit here at Greenfield Industries. I want to give a personal thanks to Rhett, Eric, and John for having us here, inviting us out to see the plant. This was the first time that I had an opportunity to actually see in person how cutters are made, specifically drills and taps is what we saw today. So really interested in seeing the process, everything from the older machineries that's been around 50, 60 years making cutters to the new technology, CNC machines, robotic arms, adding automation to this. It was really great. Even the inventory, having, 30,000, different items there on the shelf ready to go, ready to ship out to all the distributors. This really was an amazing place, and I just want to extend my personal thanks to everyone at Greenfield Industries and of course Walter for allowing us to come out here and see the factory and taking the tour, taking the time to walk us through there and explaining the processes to us and letting us get video so that we could share that with our audience here on the channel. So I hope you guys watched and enjoyed the video. Thank you again, Greenfield Industries. We absolutely loved our visit here.